Actually, I thought of starting, since I'm in a nice Windows 8 application on screen, I actually thought of starting in that tile and doing a little bit of live tile, but it doesn't really work. So good morning again. Quite a heavy session, I think, for the first thing tomorrow. This session will be OAuth as a service using ASP.NET Web API and Windows Azure Access Control. So really a lot of information packed in one session. The main idea is actually probably who has been consuming Twitter or Facebook in their applications? Okay, a couple of guys. Other applications that you've been consuming? Okay, again, a couple of guys. This will not be OAuth from the consumer side of view, but it will be OAuth from the producer side. So if you have an application, if you have an API, and you want to expose all your services or your APIs in a secure way, you actually want to use OAuth, and that's what this talk will be about. Now, one thing is, if you are using OAuth, it's actually quite difficult to write everything that's required to do the entire flow. So the idea is we can use Windows Azure Access Control to improve everything there. So I'm Maarten Maljouw. I work for JetBrains. We have a booth here, so if you want to come by, feel free to pass by. If you have questions after the talk, also come to our booth, and I'll be happy to talk with you. Here in Belgium, I also run the Azure user group, so if you're interested in Windows Azure, feel free to join our events. Our next one is on Monday, by the way. My main focus is web, so everything related to ASP.NET, everything related to ASP.NET MVC, SignalR, jQuery, JavaScript frameworks, Windows Azure, and things like that. If you want to buy me a beer, you can either come to me and buy me a beer, which is also good. You can also buy our book on NuGet, which I wrote together with a former colleague, which buys me half a beer, actually, so, but feel free to buy anyway. So the agenda for today. Let me start with another question. Who of you has been building an API? Okay, a couple of guys. Who is thinking about building an API? Okay, again, a couple of guys. So for those who are still in doubt, I'll start with why you might want to have an API in your application or in your organization. Then I'll focus a little bit on API characteristics. So an API can basically be anything what you want. It can be a .cf service, it can be SOAP messaging, whatever you want. The APIs I will be talking about in this talk are the REST-based web APIs that are available today throughout the internet. I'll also give you a quick primer into ASP.NET Web API in case you haven't seen it. And I'll show you where you can actually hook into the framework, into the pipeline, whenever you have a request coming in, where you can inspect message headers and things like that and act on that. So if you have a user coming in, you can inspect it and have the user in your application. And then, of course, Windows Azure is another part of the talk. So what I'll be doing is actually delegating all the OAuth work to Windows Azure and just build my API and have Azure do the entire OAuth flow and the entire OAuth dance. So why would you need an API? First of all, don't pin me on any of the dates, but if you look at how we've been consuming the internet, I think we've been consuming the internet using our desktop or our laptop browser previously, which is a very good way of consuming the internet. But around 2008 or maybe earlier, the first mobile browsers came about. So we started using, I still remember I had a Sony Ericsson, which had I think not even an Edge connection, and it had WAP pages on them. So a condensed form of HTML. But yet, doing that, the first web consumption using mobile devices came about. And it's been evolving, and now on your smartphone, you can actually browse to any website you have using the browser on that device. So that also works. Now, some strange corporation with a broken Apple logo or something, they came about with the iPhone. And what they did, they introduced apps. So the idea was, let's not use a browser to navigate the internet. Let's build applications that allow you to retrieve data from the internet anyway, but consume them in a format that's really native to the device. Android did that, Windows Phone did that, Windows 8 is doing that. So everyone is building apps, and those apps are still consuming the internet, still consuming services and data coming from the internet, but they are not consuming them using a browser. And of course, more and more tablets are coming, and more apps on those tablets are coming. Those applications are getting more complex than the applications you see on your smartphone by default. which means those applications may be consuming multiple services at once and combining them in the experience of your application. So tablets, 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 but again, not the browser. They are consuming the data, they are consuming the APIs, but not in the browser. And I kid you not, I think in the future we will see many more devices accessing the internet and consuming services. I have a fridge as an example, and I'll give you a quick example. There's actually a fridge which has internet access. But a better example may be like a thermostat. You have your central heating in your house and you have a smart thermostat connected to the internet, and it can actually query the weather for your house, query the weather where you live, and depending on that it may decide to maybe not heat the house as much as possible because it's spring or something is happening where the outside temperature is higher, and the thermostat can make a smart decision based on the information received from the internet. A fridge, which is a fun story actually. I've built my house almost 3 years ago, and I've seen this coming. I thought one day I will have a fridge with internet access. So since you're building, what you do is you pull a lot of cables, and I actually have a Ethernet connection behind my current fridge, which is not internet enabled. But I think this one is a nice one. Samsung has one. And they actually have apps on the fridge. So if you want to tweet every morning that you are out of milk or out of coffee, you can do it from your fridge. But it may make sense to have applications on there to look at the weather, look at the news in the morning whenever you are first in the kitchen. So I think there's value in having these things. But again, it's not using a browser, it's just consuming data and services from the internet. So maybe by show of hands, just to prove my point a little more, and I hope I can prove it, who of you is using Twitter or Facebook? And who of you are mainly doing it using the website? That's like 2 people raising their hand on websites, and the other ones are probably using apps on their smartphone or their tablets to consume these services. So again, these 2 companies actually, I think they owe a lot of their success based on the fact that they have an API available, that they themselves and third parties can build apps on those to consume the service you have on Twitter and Facebook. So I think there's a lot of value in having apps to reach more clients, actually. If you have an application for all the different devices, for all the different tablets, perhaps you will have a larger user base by just exposing your services through the browser and through an API. So as the French say, and thank you, Christophe, for this quote, as the French say, make everyone happy. So if you want to expose a service to third parties, there's a couple of rules you have to think about. First rule is make sure your API that you are exposing is valuable. If it's consumer to consumer or business to consumer, make sure the consumer knows what to do with the information and really can do something with the information. If you're doing business to business communications using your APIs, make sure the business value is there. Don't just put out yet another string reverser or yet another base64 encoder on the internet. I think there's APIs enough doing that. Except if you have a lot of weather data, I wouldn't probably put yet another weather API on the internet, but make sure that for your business, for the things that you are doing, your API is valuable. Either because of the data that's coming out of the API or either because of the services that are coming out of the API. So for example, if you look at GitHub, right, I think everyone will know GitHub. It's a source control hosting company on the internet. What they have in their API is a couple of things. First of all, their data is pretty valuable. There's a lot of open source and closed source projects on GitHub, and they have a lot of data, so you can, if you're a consumer and you go to GitHub, you can actually download code, and there's value in that because you can use it in your own applications. Now, their API also is quite valuable because they also have all the metadata in there. You will know which project is owned by which user. If you query the user, you will also get a link to their profile. You will also get a link to their photo and things like that. So if you wanted to build an application for browsing GitHub, you can basically get all the information and you can really build something on top of it. Even more interesting, you can combine different services like GitHub, Codeplex, Stack Overflow, and things like that to get a developer profile, for example. Know which developer is doing what on the internet on all the different websites. So by having those things, either combined or separate, you should provide value to your customers, either direct or through mixing it with other services. Also make your API flexible. The last thing you want to do, and actually I have a pretty good example on that. I think 3 years ago, I was talking to David Terny, and he gave me one of the prototype Windows Phone 7s. And I'm still using that because it's like almost the only device which has a hardware keyboard in it. Fun thing is, I downloaded and installed a Twitter application on that 3 years ago. I haven't actually did a factory reset since then. And I'm a bit afraid of doing that because the marketplace is even closed for that device, so I cannot do anything with it anymore. But still, the application is on there, and still I can tweet from my phone. So make sure your API is flexible. So if I, as a consumer, do not update my app and do not update the logic in that application, make sure that I can still consume your API, either because the API version keeps existing, or either because you're making it really backwards compatible, and you're making sure that whoever wants to use the API can still use it, even though there's new services introduced. Also, manage your API. If you go to GitHub, if you go to Twitter, I think Facebook has the same things. They have a status dashboard where every API, every endpoint of their API is monitored, and you can get a status of all the APIs. So you can actually see if Twitter is down or part of Twitter is down. You will see which service calls will work in the API and which will not. So manage whatever you're doing, monitor whatever you're doing. Also support your API. An interesting one there is Twilio. That's a company doing basically your phone calls and SMS and things like that as a service on the internet. They also have an API. Now the fun thing is they support their API pretty good. The company is actually bringing out SDKs for all the different platforms, for all the different devices. And if you have a question, you can just ask them and they will support you. And they even proactively monitor Twitter and things like that. If you are complaining about them or you don't know how to do something, they will monitor it and someone will be in touch. So support your API and your reach will even grow wider. People will start to use it and people consuming it will have a fun experience instead of, just fighting with your API. Last but not least, have a plan about what you will do with your API. If you've been to my talk, and that's a typical TechDays thing, I think everyone will be going home with like, yay, that's a really cool feature, and to the cloud, and APIs, and things like that. Think about it, have a plan. Don't just put an API out there, support it for 1 year, and then after 1 year, still have it there, but no longer support it, have an unreliable API, and things like that. Make sure you have a plan about what you're going to do with your API, and keep it there, and keep it valuable and flexible and managed, etc. The main idea of APIs is to reach more clients. So again, the list of devices I had, you had your browsers, you had your applications, things like that. If you only support browsers, you can reach quite a lot of customers, but I think if you have applications, you can even reach more customers. And if you have applications for all the devices, you will reach even more customers. Also, you're not the only one. Actually, there's quite an explosion in the APIs available on the internet. There's actually, I don't think the URL is on there, but there's a website, the Programmable Web, which has a list of all the APIs they know. So if you're building an API, you can submit it there. And they basically keep track of things like how many APIs are there, what technologies are the APIs using, and things like that. So if you want to discover trends in those things, they have charts like this one, for example. And you can see there's been a huge boom in building APIs. So if you start producing an API, you're definitely not the only one doing this. Now some characteristics. What is an API? I think the word API has kind of two meanings. I think a couple of years ago, an API was simply a model to which you program, like you have the API for .NET, for example. APIs nowadays have the connotation of being services on the internet, like software to software, where you have an application consuming the service on the internet. Enough of that, it's just a definition. If you look at the internet, there's actually a lot of flavors of APIs. And I think we've been using quite a lot of these even before. There's APIs using HTTP as their transport mechanisms. There's APIs using sockets. There's APIs using email. There's actually a fun RFC on Wikipedia which uses postal doves to actually deliver messages. It's not a real API, but anyway, it's fun to read the spec actually. On top of those transports, we have different kinds of data formats going over the wire. I think most of you have been using SOAP or XML or something like that in previous projects with ASMX services, with WCF and things like that. There's binary if you're using WCF, there's binary if you're using web-based APIs, there's JSON, there's text files, there's images, whatever you want to do. There's a lot of message contracts, but this talk, the rest of this talk, will basically focus on two things: HTTP and the JSON or XML message contracts that you can put on top of them. Now, if you look at those APIs, most APIs using HTTP and REST-based URLs and JSON or SOAP or whatever format they use these kind of things. They use addressing. So for example, if you're having a customer service written in WCF and you're not using a REST-based API, what you will have is a get customer service, which gets a customer from your database and returns it to the user. Using the addressing defined by REST, you actually have a resource address. So if you need a specific customer, you will go to API/customer/1 or API/customer/Microsoft or something like that. You will have a defined address for getting one specific piece of data from your API. So you will not have service calls, but instead you will just have addresses for every resource that may be in your data store or on your service layer. These APIs typically also use HTTP verbs. If you look at SOAP, for example, there's a lot of extra metadata that you can inject in your messages, where you can actually tell the service what to do with the message. Not with HTTP-based APIs. What you will do is basically abuse the HTTP protocol to express your intent. So for example, I don't know if you know it, but if you do HTML and web development, you will have GET and POST requests to your web server. A GET request expresses the intent that you want to retrieve data from the service. A POST request expresses the intent that you want to post some data to the service. So actually using all those keywords, and there's way more than those two, you can express what you want to do to the API, so you don't have to put it in your message that you're sending. You just use the protocol to define what you want to do. There's also things like media types. If you browse the internet, and the internet is actually a perfect HTTP-based web API, you will see that you have HTML documents, there's some XML on the internet, there's maybe images, PDF files, things like that. Those are media types, and you can actually, using the HTTP protocol, you can tell your server which data format you are sending to the server and which formats you want to retrieve. And you can even express multiple of those that you want to retrieve, because the server may not respect the first thing. But maybe if you say, I also accept text, it will send you text if it doesn't support XML, for example. Then again, you also have status codes, which is also an interesting one. Why would you define a message contract that tells you a customer is not found? Use HTTP for that. Return a 404 not found, and the client of your API will know when calling the server that whenever the customer is not found, it will retrieve a 404 not found, like you see on the internet. If something is wrong at the server, maybe you want to give some exception details, but typically something is wrong, well, show a 500. Just say the server did something wrong, something went wrong on the server, and you can try again as a client. Another interesting one is hypermedia, which is kind of discussed in the Twitterverse. There's actually a maturity level if you look at APIs. So every API that you put on the internet will have a maturity level, and the highest maturity level also supports hypermedia. What is hypermedia? You actually all use it daily, I think, when browsing the internet. Hypermedia is basically expressing that related to the resource you have queried from the server, there's also other resources. And the best example is actually if you look at the internet. I'm going to show you. That's actually a pretty slow slide. If you look at the internet, and I go to Google, or Bing, or whatever, and let's search for hypermedia. This is hypermedia. I get a resource, namely the thing I asked at Google is give me the search results for hypermedia. And Google gives me the search results plus links to other resources that are related to the query I did on Google. So I'm actually getting the result back plus extra information which tells me where to go next and where to find additional information when I query this thing. And if you have a very mature API, you also want to do this. in your own API and express related resources. Another example I have of that is actually GitHub does a quite good thing in their API. If you query, for example, all the repositories someone has on GitHub, you will get back this JSON. And apparently I have not the correct resolution. But they will give back this JSON. And as you can see, there's data in there which tells you which repositories are hosted on GitHub. So for example, I can see the name there, Hello World, full name, Octocat Hello World, and things like that. But the fun thing is they also embed URLs to other resources. So they have the URL in there, which is, if you want to browse this repository, that's the URL where it lives. You can find the owner in there, which is related information. For the owner, we have an avatar URL. So we can actually query for an image of this specific avatar. There's things like a Git URL. There's things like an SVN URL. So based on what I want to do with my API as a client, I can use all this information to build my application and basically query a resource and get all the related information for free using Hypermedia. So the web is actually a perfect example, and GitHub is also a perfect example of how to build your API. A little bit more on HTTP verbs. There's a couple of them. There's get, there's post, there's put, there's delete, there's merge, there's prop find, there's patch, there's a lot. But these are, I think, the most used on the internet. Get will typically express the intent to the server that you want to get data. A post and a put will express to the server that you want to give it some data and should do something with it. A merge, which is an interesting one. I think maybe Yves will show it later today in his talk on Windows Azure Storage as well. It's an interesting one. Say you have a CRM application and you're exposing it as an API, and you want to store a person or a company. The last thing you want to do is, if you have a cell phone consuming that API and you're on an edge connection, the last thing you want to do is send 1 megabyte of XML data to the server, giving all the properties that may not have even changed, but you still have to send the entire entity. The merge keyword, if you use that, you are actually expressing that the data you are sending, you want it merged with the actual resource. So if you changed only the address, you would send the address to the server, together with a merge keyword, and your API should know that the resource you are accessing should be merged with the data that you are sending from the client, and you can reduce bandwidth using that. Delete is also an obvious one, to delete a resource from the server. Looking at status codes, there's actually a few categories. In the 200 range, you will see things like 200 OK. So the request you've done, everything is OK, I'll give you the data just like you asked me. There's a 201 created, so if you're sending data to the server and you want the server to respond with something like, okay, I've created the resource you've asked for, you can return a 201 created. There's the 300 range, which is basically status information at the transport level, so you can do things like redirection and so on. 400 level basically means that the client is doing something wrong. So for example, if I go to a web page which does not exist, I will retrieve a 404 not found. That's basically telling the client, look, the address you are using is not a correct address to a correct resource. It doesn't exist. I can also return a 401 or a 403 to express to the client that he should log in or he doesn't have the correct credentials to access the resource he's trying to access. The 500 range is all the server-side errors. So we have an error 500, for example. You've probably seen it when doing web development, internal server error. So you can actually express to the client that something at the server side didn't go well and something went wrong there. There's one thing. If you're building your API, make sure you are being detailed. There's actually a very good RFC, 2324. Who knows this one? You should read RFCs. It's actually very interesting. I have no life. You should be detailed. This is the hypertext coffee pot protocol. It's actually an April Fool's joke, which you can also find on Wikipedia. But it's a perfect example of how you can be specific with your API. And actually, I really have no life. I've been building it using ASP.NET Web API. So you can simulate requests using the HTTP hypertext coffee pot protocol. So what we can do is, if we use Fiddler, we can send a brew request to our coffee pot protocol endpoints, and we can give it some content types and additions and things like that. So this is a very specific API. I'm not using the post keyword, I'm using the brew keyword. Make me a coffee. I can express what I want from the server there. I'm also telling it I want milk and cream in it. I'm also saying the content type, so the data that I am sending to the server, is of the type message/coffee pot, which is the thing you see below. I'm sending a coffee message body equals start. So I'm telling the coffee machine to start brewing my coffee. So if I do this, and let's say I use coffee pot 2, I can send it. And if everything goes well, I will receive, if I look at the response, a 201 created. If I'm implementing this, I will just get a 201, and I know that my brew has been created, that my data has been accepted, and everything went according to plan. Now, talking on being specific, if you query coffee pot 1 and you want to brew coffee in there, this one will return an error, 418, which is a made-up error code, but it says I'm a teapot. So doing this, I'm being very specific about the data I'm returning, and I'm actually telling this thing does not support brewing coffee. If you want tea, okay, but not coffee. So be detailed, be specific on what you're returning and what you're trying to express using all the HTTP verbs and things like that. Okay, ASP.NET Web API. Who of you has never used ASP.NET Web API? I won't shoot you if you raise your hand, so okay, a couple of guys. I'm going to give you a quick introduction on what it is. By the way, those guys who raised their hand, and girls, have you been using MVC? Okay, a couple. Web API is basically similar to ASP.NET MVC in the fact that it uses the paradigm of having controllers and action methods on which you can call data and which you can query for retrieving data. It has things like content negotiation. So for example, if you send a query to the Web API and you tell it I want to have XML returned or JSON returned, Web API will inspect that and give you the format back that you actually expressed from the client side. It has routing, so you can make pretty URLs, you can have meaningful URLs, which again is very important if you're building a REST client. You should think about the addressing. It has things like action filters, for example. In MVC, if you want to have an authorization required for a specific action method, while in Web API you can do the same thing. You can add that filter to an action method or to a controller, and it will require you to authenticate prior to using your API. Way more in there, but just to give you an idea. If you don't know Web API and you haven't ever used it, these are the most important things. The HTTP verb you are using, so get, post, delete, merge, things like that, those are the actions by default. It's the default, you can actually change it, but by default, those things are the action. So if I do a get to a specific controller, on that controller, the get action method will be called. I can send a content type header to the server, and the content type header is to inform the server of what data format I'm sending to it. So if I say I'm sending you a content type of application/JSON, the server will know it should parse it using a JSON serializer and fetch the data from that thing. The accept header is the other direction. It will tell the server the order in which data formats you can receive data. So if you say, I accept application/JSON again, the server will know it has to encode your data into a JSON format and return it over the wire. Again, think about meaningful status codes. By default, if you do something, it will always return a 200, but return meaningful status codes in your application as well. I'm going to give a very quick demo on what you can do with Web API. Let's build a persons controller. Very inspiring. So what I can do is create a class, person controller, and it should be public, of course. And let's inherit not controller like you do in ASP.NET MVC, but let's inherit API controller. If I do that, I can start adding methods, and I can do something like this, where I can return a person from my get methods, or where I can return, which is also supported, even a list of persons from my get methods. Now in my body, what I can do is use my repository. Let's use that one. And what we simply can do is return repo.get. And this actually will return all the persons that are in my application. It's easy as that. I have an API now. So if I run this, and I use my fiddler, and I use, let me just use this one as the base, and I query the person endpoint using the get keyword. If I query it like this, I will get a response back from the server, which is this one. 200 OK, so the thing I expressed as my intent to the server is all satisfied, it's OK with it, and it's giving me back a person array, in fact, containing just one person with a name in there. Fun thing is, I told you about the headers that you can send. So if I say I accept text/XML in my request, you will see that Web API actually inspects this data, and instead of JSON, which it did before, it will return an array in XML format, which is, again, a really interesting concept. Because I have my resource address, I may have a person in my CRM, and if I query it with a data type of text XML or with JSON, for example, it can return the entire person object. But what would happen if I query this service using an accept image/JPEG? I can maybe return a picture of this employee coming from the same endpoint. It's the same resource. It's the same person that we're talking about, just because I'm using a different data type that I want to have over the wire, I can get back a different result. So, for example, an object versus an image. And you can actually plug in there as well. So if you want to do invoicing for that person, and you say, I want a PDF, you can get back whatever you want from that. So that's Web API in a very, very, very short demo. There's more in there, but I just want to give you a feeling that it's really easy to do it, and really easy to do it in the correct way. Now, talking about security, which is actually this talk, it's kind of hard to do with Web API. So what you can do is, just like in MVC, you can add the authorize attribute on top of your controller or on top of your action, and the framework will see if the user is logged in or not, or has a specific role or not, or has a specific username or not. But how does the API know which user is calling the API? I mean, if I'm using a client application and I do an API call from my Windows Phone application, for example, the last thing I want to do is redirect the user to whatever login page there is, log in there, and then use basic authentication or set a cookie or something like that. The things we do in a browser just don't always work with an API. And in fact, there's something lacking in the framework there. There's no real support for adding things like authentication. It can check the user who is on your IIS or on your web server that you're using, but it doesn't really provide a mechanism to initiate the login. It's not like you get, like in MVC, you get an accounts controller where you can log in, where you can register and things like that. You don't get anything like that with Web API. It wouldn't make sense, actually. But luckily, and that's what I wanted to show you in Web API, and that's why I did the small demo, you can do something about it. So I created a second controller, which is this one, the super secret controller. And if I query this using Fiddler, it should return me with hello, comma, and then the user who is logged in. So I'm just using everything you know from HTTP and web programming in Visual Studio. It gives me back a user object, which contains the identity of the username, is he logged in, the roles, things like that. So I'm just using that, and I've added the authorize attribute there. Even funnier, if I query this controller, it's super secret. There we go. And I query this, I will get back an error 401 saying that I'm not authorized. You're unauthorized, and it's also giving me a message about why this error occurred. So again, it's very specific. Now, how can I plug in authentication into this? There's no default way of doing this, but luckily the pipeline of ASP.NET Web API is very extensible. So one of the earliest places where you can plug into the pipeline is using handlers. So just like you do with MVC or with web forms and things like that, you can plug in handlers. You can do the same with Web API. Of course, you have to configure it and register it. So in my application startup, I added to the message handlers a new instance of this thing. Now, the fun thing is, what I can do in those handlers is basically everything. I can query headers, I can set cookies, I can get cookies, I can do whatever I want to do. So the example I created here is I'm checking if there's an XAPI key header in the request. If that thing is there, I'm querying my database, which is this thing, to basically recognize the API key being passed, and I get the username back, which I can use in the application. Next thing I'm doing, creating a new identity, putting it on my thread, and if I'm hosted in IIS and the basic .NET framework hosts, I also have to put it on my HTTP context. So that's basically what's happening. I'm checking a header and creating an identity for that. And by doing that, I can simply write my code like this and use everything you know from the framework and everything that's available in the framework. So I'm going to give you a quick example as well. In my requests, I can add my X API key and say 1, 2, 3, 4, 6. Let's execute it. I'm coming to my handler first. I'll also put a breakpoint here. I'm going in my handler. I'm getting the API key from my headers. I'm creating a new identity, putting it on my current thread, creating the identity in Internet Explorer and things like that, or in my HTTP context. I go through. I'm coming in my controller. It has an identity, so it's not a null reference. And if we look again in filler, what we will see is a nice response, not a 401 this time, but a 200 OK, and my username is in there. If I use a different API key, 1, 2, 3, 4, 5, I will get a different user back. So let's just run through it. I will get back hello Martin. So by plugging into this pipeline, you can actually provide a framework with identity data. And keep that in mind. If we go to OAuth, we will need something parsing the incoming OAuth token to do something with it and provide it to the framework so we can just use the user and whatever data is in the OAuth token. Cool. There's a lot of different API clients. So there's mobile clients, there's tablets, there's web browsers, there's fridges. There's a lot of things you can use to consume your API. Also, there's a lot of different mechanisms of authenticating. There's username, password, there's Kerberos, there's Windows authentication, there's, you name it, client certificates that you can use. And you can even do, maybe you don't have a real client application that a user is using, maybe you do server-to-server stuff. There's a lot of different aspects to how you would protect your API in all these different situations. And actually, OAuth provides you with a framework, not a real implementation, but with a framework of building a flow that supports basically everything that's in here. Of course, not all the authentication or not all the authorization mechanisms, but it supports all these different clients. Who of you has been using Windows Azure? That's quite a few. If you go to the portal, you will see you have different services that you can consume. Actually, that's a server-to-server OAuth that they are using. So in the back, they have all these different services, all these different APIs for creating new virtual machines, things like that. The portal you are using is OAuth to communicate with that thing, so that's a server-to-server thing. You can have HTML5 applications, like one of those things I really dislike. If you're on Facebook, from every now and then you get a request to have your birthday listed somewhere in a calendar. Typically, that's OAuth again, but in a browser. If you use a Twitter application on your phone, you will be redirected to Twitter. You have to log in there. You get back to the application. That's OAuth from a mobile device. So OAuth basically covers all these scenarios in different flows. The thing is, in a lot of public APIs that you consume either through an application or to an application in the browser, the thing with those APIs is that your API consumer, so the thing querying your API, is not really your user. It's just a piece of software acting on behalf of a user. Or the API consumer is not your user. Who of you is like this right now? That's where OAuth comes in, actually. So a perfect example of OAuth would be, since OAuth, if you go and read the specs, there's actually no technical implementation in there. This is OAuth. I think every one of you has a badge like this. This is perfect OAuth. If you look at it, and if you look at it from a broad angle, like from the registration point, I had to go to the website of TechDays to retrieve a ticket containing a barcode, which I should hand to the reception, which gives me this badge. And the badge states that I can access Kinepolis on behalf of Microsoft for a period from 5 to 7 March. And because of the color of the lanyard, it means I'm a speaker. So there's a lot of information in this badge, and it's perfect OAuth, in fact. So let me explain. This is actually the thing you will find in the spec. I just changed all the data that's on there. But this is what will happen. I am the client. I'm not here on behalf of me, I'm here actually on behalf of Microsoft. Microsoft granted me access to this building. So I am the client, but Microsoft is the actual user of Kinepolis. I'm not the user of Kinepolis, Microsoft is. I'm here on their behalf. So what I did is register for a TechDays ticket from the resource owner, namely Microsoft. They are organizing the conference, so they own the resource, they own the fact that they exposed Kinepolis for 3 days to have this conference. They hand me back an e-ticket, which contains this barcode. Now, 2 days ago, I was invited, yay, I have this barcode, so I have to go to an authorization server, in this case, the reception. I have to give this barcode, and in exchange for the barcode, I receive this badge, which contains all the information anyone in here needs to know who I am, what I'm doing here, on whose behalf I am here, how long I can be here, and if I can be here in front or not. So I get this badge with all this information on there. And whenever I enter a room, the resource server, Kinepolis, will check this badge and see if I'm a speaker, so I can enter earlier than general audience, and if I can still enter. So if I come here tomorrow, when the conference is over, my date says you're only allowed to be here until the 7th of March, which is today. I cannot come back in tomorrow. So everything is covered. Everything we have in the OAuth flow is covered using this badge. And one important statement there is, next year, if I want to come, I have to refresh my badge. I cannot come in with this badge again because the date is not valid and I have not been validated by, again, the authorization server, which is the reception. So to put everything into context in OAuth, I've created a little overview of all the elements in the sentence, in the statement I made before. So I am the client. The access code or the barcode I received on my e-ticket is the access code I have to access the conference here. The reception is the authorization server. So they authorize me because I have this access code. They know that I'm registered and they can give me a badge in return. And the badge is the access token. Kinepolis is the resource server. So Kinepolis is actually my API in the OAuth flow. The fact that I'm a speaker, so the fact that I have this color of a lanyard means that I'm a speaker. So that's the scope. What can I do here? If you go to the speaker's room, the mean-looking guy who's standing there will probably kick you out. I will get access because I have this scope of access on this access token. Also, the token lifetime is on there. If you didn't register for the pre-conference or the technical deep dive, yours will probably say 6th and 7th of March and not the 5th. So if you've come on the 5th, first of all, the authorization server wouldn't have given you your badge. But second of all, if you wanted to come in with a badge that only has those 2 days mentioned, they would probably deny you access because of that. The fun thing is security. If you enter this room, for example, they don't have to go to the resource owner again. So they don't have to go to Microsoft to check if I can access this room, if I can access this conference. They trust it because this badge has been issued by a trusted party, which is Microsoft, which is the reception. And everyone in here knows they should respect this badge because it's a validated protocol in there. So there's a lot of stuff which is in here. I'm sorry if you feel like this right now, but I'll make it even more complex. So this is the actual flow coming from the spec. And the idea is if you have a client, which is, again, not your user, if you use Twitter, for example, on your cell phone, what will happen is the client will make an authorization request to the resource owner. In this case, a very funny fact, you are the resource owner. You own the Twitter account that you're trying to consume from your client application. So the client application will ask you if you want to give access to your protected resource, which is your Twitter timeline, for example. And the first time you use a Twitter application or a Facebook application or a lot of applications, the thing that will happen is you go there, they ask you to log in, and you have to confirm what you want to do. So for example, if you go to Twitter, it will give you an overview. Do you trust this application to access your timeline, see who are your friends, see who you are following on your behalf? You say yes or no, and that's the grant that's coming back. The thing that will happen is you will actually give the client a code to go to an authorization server where they can exchange the code for an access token. So again, the codes they receive from you transparently in the application, but still, Twitter will give the clients a code that they can exchange for an access token. And that access token contains all the information the client needs to access a protected resource, which is on your resource server, your API, and to provide it with all the necessary information. So typically an access token will contain, again, validity. How long is this token valid? It will contain a scope. What can you do? So for example, some applications only access your timeline. Some applications want to post to your timeline. So that's a different scope there. And depending on the token, if my token states that I can only access and read data there, they cannot write on the API. So that's the real OAuth protocol you have. There's some variations on that, depending if you want to do server-to-server communications and things like that, but this is the general flow you will see. Again, this is not a technical implementation. OAuth is basically just what I just told you. Another fun fact is, did anyone see the word login in this entire process? No. OAuth is actually just authorization. It's basically the means of asking the resource owner to provide access to their protected resources and have an authorization server sitting in the middle to create a token, a trusted token that the client and the server can use to validate all the requests that are available. Of course, in the example of Twitter, you will have to log into Twitter before you get the yes and no choice, but that's entirely up to the resource owner how you do it. If you want to just query a URL and retrieve the code immediately, you can build it. The protocol, OAuth, doesn't really specify that you have to log in there. Just looking who's in the audience doing this. No one? Okay, let's come up with an example just to make it even more clear. A friend of mine who's doing a presentation here as well has built a nice application, Hoeleven. It allows you to do getting things done and basically plan everything that you have in your personal life. I can join and I can log in using Facebook. This is the client, and Hoeleven.com will want to access Facebook on my behalf. Again, client, I am the resource owner. I'm going to Facebook, and since I'm already logged in there, it will ask me some things. So Facebook will ask me if I want to go to this application, and if I trust this application to view my basic info and my email address. So it's telling me what the application wants to do with my resources, and I can grant access or deny access. If I say go to app, what will happen is the application returns a code to this website, Hoeleven. They exchange the code for an access token with Facebook, and they have access to whatever I have in my Facebook profile. So this is the flow we've just seen in the schema. I already did this note, but basically there's a couple of variants on OAuth depending on the type of client. So for example, if you have a mobile device, maybe you don't want to use the browser to authenticate and do all those things. Maybe if you have a browser, you want to skip some part in the flow, but still the exchange of codes and access token should happen, but you can do whatever you want in between. So if you want to do basic authentication to the server to retrieve the access code, no problem there, you can do it perfectly. I'm going to skip those two. Well, not this one. Okay, so the first thing we did is we queried the resource owner. We went to the authorization server and we retrieved an access token. Now, the access token, again, like with the badges, you have a limited validity on there. So it expires in 3 days, for example. The same thing will happen with a lot of public APIs you query, and maybe you want to do the same with your API as well. The idea is to also have refresh tokens. So whenever my batch expires, I have to go back to the authorization server to query a new token, just to keep access to the API I'm having. The reason why you would want to do this is because your resource server is not communicating with the resource owner or the authorization server at all. So this means that it's basically the example of me wanting to enter this room. If I cannot enter, or if I can enter today, and they see that I cannot enter tomorrow, they will just deny me access. They trust the badge. They don't go to reception. They don't run a query on the database of all the attendees here. They will just trust the badge. If I want to come here tomorrow, and it would be TechDays again, and I don't have an 8 in here, I would have to go back to the reception and try to exchange this access token for a new one, which has a longer validity again. Why would you want to do this? Well, if you want to deny access to a given user at a given time, you probably don't want to have an access token that is valid until the end of times, because that would mean your resource server will have to grant access all the time because it has to trust the access token. So if you want to have some kind of user expiration or you want to have some check that the user still has access to your API, you want to have a short validity of the token. Because if you only have 1 day, for example, as a validity, you have to go to the authorization server daily to check if you still have access. If you don't have access, you will get a token which contains a different scope, and your API, your resource server again, will immediately know that you cannot access the API again because the token is no longer the same and no longer containing the same scope information. The access tokens and the refresh tokens can, in theory, again, the OAuth framework doesn't really specify an implementation. In theory, it can be whatever you want. So in the example of TechDays, it's an access badge. In the example of Twitter, it will be a JWT token, so a JSON web token, just containing some simple JSON data. Some other applications use SWT, so a simple web token, different formats. Some use XML, some use a CSV, separated string, as the access token. So basically, you can do whatever you want with it. I would suggest you either sign, preferably, and or encrypt the token. The reason for that is you should have some trust relationship between your resource server and your authorization server. If the authorization server signs the token with a signature, which is also known by the resource server, the resource server can actually know that you're accessing it and have been validated through a trusted endpoint, so the authorization server. Here's what it looks like, the token. There's basically 2 objects in the JWT token. The first of all, you have the header, which contains, you see the ALG, that's the algorithm of signature. In this case, this token is not signed, so this is not a really secure token. But if you sign the token, you would just put the method you used in there to sign the token in there. Then you have the token itself, and you see a lot of information in there as well. So the ISS is the issuer of the token, is Joe. This means that this token has been provided by the resource owner, so by me. If I go to Twitter, the issuer will contain my Twitter username because I basically was okay with the fact that this token would be issued by the authorization server. The EXP is the expiration timestamp. So you see there's always an expiration on this type of token. And you also see there's some strange HTTP URL in there with a true as the value. That's basically the scope. So you can have one scope, you can have multiple scopes, but the idea is you pass in a token what you want to provide as a service. So if you want to give access to your customers, this thing would probably contain customers true or something like that, something to know on the resource server what the user can do. So you put something in there, and it can be multiple things as well. Again, authorization, authentication. Is OAuth different from OpenID? Yes, it is. OpenID is really for authentication. OAuth 2 is really for authorization. So OAuth 2 doesn't specify that you actually should log in anywhere. It's just a flow of tokens and trust they describe. So if you want to do something like authentication on a public website, maybe you want to go with OpenID. There's 2 URLs. I will put the slides on my blog afterwards, and I think they'll be on the TechDays website as well. But if you go to those URLs, they actually explain the difference between the 2 and how they can go together. So if you're interested in that, feel free to check. Now, if you, as a producer of a service, if you as a resource server want to have this entire OAuth flow, you have to do a lot of things. First of all, you have to build your OAuth authorization server. So the fact that someone can come to the server with a code and retrieve an access token. That means you have to keep track of supported consumers. You have to keep track of all the applications that can consume, maybe at some given point in time, that can consume your resources. You have to keep track of user consent. Because if a user denies access to a given application, you want to have that information somewhere in the authorization server to know that that user or that application should never get a token on behalf of that user to access the resources because the user denied access. You have to keep track of token expiration. So you have to have something in place if the date range expires to do the refresh, to check the database again, to check if the user actually granted access for you to go to a resource server. Oh, and by the way, you still have to build your API as well. So it's a lot of work to do this all manually. So if I heard this the first time, I was something like this. But then I found out about the Windows Azure Access Control Service. Who of you have been using this one before? Not too many, actually. So I'm surprised because it's a great service. The things it does is a lot of things. You can compare it with a service or with like a BizTalk for identity. You can have multiple different endpoints which you can consume. You can have multiple identity providers, and you can just wire them together in access control. So maybe I can give you an example of that one as well. That's a small side project I'm building, which is MyGet. We're using access control to do the sign-in. So if I do sign-in, and this list of identity providers is basically access control service. Now it's all social identity providers, but it can also be your Active Directory or whatever you want to have in there. I can click there. I go to Windows Live ID or Microsoft account. I get logged in, and I get redirected back and things like that. And you see, this went really quick, but my application doesn't have to account for all these different methods of logging in. The only thing my application has to care about is the fact that ACS says I should trust this user or not. That's the only thing I have to build in my application. And ACS does all the other orchestration, making sure that a username from Twitter maps to the same property in the token as a username from Facebook or from Active Directory, etc. So that's what ACS does. It also has single sign-on. So if you're signed in to Windows Live ID, I now just click the Windows Live ID, and I was logged in immediately. I didn't have to provide credentials again. It supports a lot of protocols. It supports a lot of security tokens and things like that. And this is usually the list you will find on many public websites. Now, there's one important thing, and a very little known feature, which is OAuth 2 delegation in ACS. So the fact that Microsoft trusts me to access this complex, that's a delegation. They have delegated all this information through a batch to the resource server, which is Kinepolis. So you can actually do that mechanism through the ACS service. The flow gets a little bit different. And again, OAuth 2 just permits this. You can do this with OAuth 2. The flow is a little bit different in that you still have to do a token request to the resource owner. So if I'm using a client application, the client application still has to ask me if I want to provide access to my protected resources. The only difference is if they say yes or if they say no. I don't store it in my own database that they granted access. I store it on ACS. ACS responds with an access code, which I give to the client. And from that moment on, the client can use that access code to go to ACS, request an access token, and ACS will return an access token. If my token expires, if my batch expires, the refresh flow is also handled by ACS. So the access token also contains a refresh code. And if I use that refresh code, I can just go again to ACS, and they will give me back a new token with a longer validity and so on. So basically, that entire OAuth protocol dance can be handled by ACS. The only thing I still have to do is build a page where I can log in, where I can say yes or no, and I store it on ACS. That's basically everything I have to do. So let's see how we can do it. First of all, I don't know if you've seen the Access Control Service Management portal already. This is the old one. There's a new one coming, but there's some things still missing from the new one, so I'm using the old one there. Maybe I'll just show you what I'm trying to build first. So I've been building a demo application, BrewBuddy, which is an application where I'm a home brewer, so my hobby is brewing beer. I can store my recipes there, but I thought, well, if I want to store my recipes of beer there, maybe some other people want to do it as well. So I decided to create a little website where people can store their recipes. There's public recipes and things like that as well. So you see there's a value in data. If someone wants to brew beer, my API that I would want to expose, which is the list of recipes, will be valuable and people can actually go and use it. So you see there's a lot of recipes in there with all the ingredients. By the way, this is one of my favorites in case you want to buy me a beer. The API that I'm building is actually quite simple. So what I have is a recipes controller in BrewBuddy. And the only thing it does is it provides a get method on the API. So again, if I issue a get request, it will return a list of recipes. The only thing which is different, or which is a bit strange, is I'm using the identity .name to know which recipes I should return. So if my client application is working on my behalf, it will get my list of recipes. If it's working on your behalf, it will get your list of recipes and things like that. And to do that, I just added an authorize attribute there. So my API, still everything the same, just use whatever you have in Web API. Now, of course, my client application, which is, I have too many Visual Studios open, which is this one. My brew recipes is actually a simple website that wants to access my recipes on BrewBuddy. So if I run this one, you will see it's a very simple UI. I can say, click here to connect. It will come in here, and it will see that I'm not authenticated yet. It has all the parameters required to do OAuth. It continues, and it redirects me to BrewBuddy. So actually, my application is now asking me if I want to provide consent, if I want to provide access to my list of recipes. So this is happening. Of course, I have to log in there. There we go. And then it's asking me if I want to allow this application to do some stuff. Now, this page, be detailed there as well. Tell your user what to expect from the client. Tell the user what you will be giving access to. So in this case, I'm giving access to my recipes and to my friends list. I can say, nope, take me back. Nothing will happen. I will just be redirected back. Or I can say yes, and I will be logged in. So what will happen next is I retrieve the code. So if I look at what's coming in, I retrieve an access code. So this is like the barcode you had on your e-ticket. And the next thing my client will do is authorize. So go to ACS to exchange that code for a token. And once we have the token, we can do web requests, and this application will just have the list of recipes available. So I can call the API in there. Now, a lot of things happen in the background. So if we go back, I'm not sure if it will work if I go back. No, apparently not. So a lot of things happened. First of all, prior to anything that happens, this My Brew Recipes website would have to go to brewbuddy.net to ask if they can access their API. What will happen is brewbuddy.net will give them a client ID and a client secret. So you see those in the code for the client here. Those are secrets that should be really kept secret because those identify the application that is wanting to access the protected resource. Next thing I do is if this application wants to log in, it goes to the BrewBuddy website to ask the yes or no question. So I can go there as well. It's actually this controller, which is just taking in all the stuff that's coming in. So you see it's a lot of code you have to write if you want to do it on your own. But the main thing it does is if you click yes, it creates a delegation in ACS. So what will happen is in ACS, the client ID and the username and the application that I'm trying to consume, the API, are linked together in a delegation, which is just a description of what the user can do and what they have access to. So if I look at ACS again, you will see under service identities that my brew recipes client ID, so this one I just had in code, is registered there as a known service identity. So I as an API owner, I as a resource owner, can define in ACS which clients can access my data, well, can access the services data. If we look in there, there's a password in there as well, which is the client secret, which we use to just verify that the client is actually the client he tells he is. The next thing we have is our relying party application. So we registered BrewBuddy in here, and we're returning SWT tokens if the login is succeeded. And that's basically it. So we just define the application, and we define the client. And using the API for ACS, we can add a delegation and say that the client can act on my behalf and access the application and blah, blah, blah. Now, because it's a little-known feature, I think the reason for that is I cannot really drill down into the portal. So what happened is I used my brew recipes, I created this delegation on ACS, but I cannot see all the users who are basically linked to this application. So I cannot list the users this application can act on behalf of. Now, luckily, there's a very good API for ACS, which I'm using here. It's a little OData service that you can use. So what I'm doing is I'm accessing the BrewBuddyNet EU West SB namespace. I have a username and a password for that, so the issuer and the key you see here. And the next thing I'm doing is creating a new client, getting the list of all the application, getting the list of all the identities, and getting a list of all the applications, or of all the delegations, sorry. If we run this, you'll see some more things then that are available in the portal. So you see my application BrewBuddy has a registered client, which is the My Brew recipes application. And that application can access all these users' data on the website, which is everything there is to know to generate a correct access token which you can consume on the server side. Now the fun thing is, I also defined a scope here, which is kind of broad. I'm saying you can access whatever is on there. But if you want to allow access to only recipes or only to your persons in your applications or things like that, you can limit the scope and you can actually check the scope on the server side as well. So this is basically the OAuth dance that will happen. And the client will, from now on, go to ACS again to retrieve a new access token if he wants to get access to the service. On the server side, basically to relieve you from the work of building everything there, I created a little open source project which is called Windows Azure ACS OAuth 2. There's also a NuGet package for that. And if you install that one, basically everything will be installed in your project that you need to do this entire dance using ACS. The only thing you still have to provide is, it's in the help actually, is a couple of settings, namely the signing key you are using to protect the token from being tampered with, the name of your application, so the name of the application hosting the protected resource, your API, and the service bus, the service namespace, so the access control namespace you have on Windows Azure. And that's everything you have to do. You get the yes/no page for free. It's all in there. And remember the thing I did with the API key header? That's actually also what is happening in this NuGet package. So what I'm doing there is I've created an OAuth 2 message handler, which does a lot of things like checking if the token is valid, checking all the signatures and things like that. And once everything is done, what it will do is, I think it's somewhere deep buried below. What it will do is set the identity of your current thread and your current HTTP context, and you can use it in your API. Now the fun thing is, if you go back to BrewBuddy, and we have our API there, in here I have my user.identity.name, so I can simply use whatever is in the ASP.NET framework, but because this handler is there, the OAuth tokens are parsed and I get my user basically from that handler into my application. Which brings me to another thing. If you want to do mixed mode authentication, say you want to have OAuth and basic authentication, or you have a service which is exposed to the internet, but also to your intranet, what you can do is just write your code like this, and what will happen is if someone comes in with their Windows identity, the handler will not fire, and they will be authenticated using Windows authentication. If someone comes in with an OAuth token, they will be authorized using the OAuth token, without my API having to know. So my code in here stays the same. It's just the fact that somewhere early in the pipeline, the identity may be different from what is coming in. So it's really easy to do it like this. And actually, I think there's a couple of guys in the audience who already wrote their own authorization server and their own mechanism of handling all the delegations. And I'm sure they will confirm it's a real pain, and using ACS, it's actually way more easy. So if you want to do OAuth delegations, if you want to do OAuth to protect your service, what you still have to do is build the authorization server. You still have to provide the text on the page where you say, yes, I want to provide access, or no, I don't want to do that. From that moment on, ACS will take over everything related to OAuth. So you just say to ACS, this application and this user, they belong together and they can consume whatever is in there. Also, if the refresh has to happen, if the token has expired, ACS will give you a new access token, which the client can use to access your protected resource. So the only thing you have to build is the authorization server still, talking to ACS, and your API, of course. So in conclusions, I think we've seen a lot of things. APIs are the new apps. I think that's a fact. I think if you're building a service that you want to expose on the internet or through a B2B scenario or whatever, I think you should seriously consider building an API instead of just a web application there. But make sure if you build an API, and actually it's also valid for building a web application or any application, make sure it's a valuable thing. Make sure the users have actual business value or get something they want to do or can do additionally with your API. HTTP is a perfect protocol for exposing APIs because a lot of the things you want to do are already in there. You can express your intent using HTTP verbs. You can say, I want to get data, I want to post data, I want to delete data, etc. You can express the content type you want to retrieve from the server. You can express the content type you are sending. You have status codes which describe what went wrong or what went right. So HTTP is a perfect transport mechanism because a lot of that infrastructure is already in the protocol we've been using for 20 years now. ASP.NET Web API is a perfect framework for building your APIs. The only thing is there's not a lot in there related to authentication and authorization, but you've seen using a handler, you can simply plug into that framework and make sure your application has an identity available which you can use in your application. We've seen OAuth 2. Just keep in mind, it's not a formal specification in implementation, it's just a formal specification in what the flow should be to authorize some user. And again, remember, this is also OAuth 2, in fact. Remember, if you want to build OAuth 2 things, it's actually quite hard. It's a lot of work to build all the required components of the flow. So you have to build something to track consent, to track yes or no. You need the authorization server, which will convert the access codes into a token. So you actually have to build a lot of things there. And using Windows Azure Access Control Service, you can basically take a lot of those things out of hand. So you actually have OAuth 2 as a service using ACS. With that, I thank you for being here. Enjoy your coffee, and if you have any questions, feel free to come up. Feel free to come to our JetBrains booth, and if you want to buy me a beer, our book is on there as well. Thank you.